This is a demonstration of the 8600 system simulator running on top of MACE 6.0 on top of DtCyber. I've recently been working on patches for this particular 3000 series magnetic tape controller in DtCyber, and that allowed me to work with an operating system image that's been in our archives for quite a long time that's dependent on this tape controller, the Dead Start. It's a backup of a system that was used in the Chippewa labs while developing the 8600. And most everything on it is from around 1974, when I believe the project was canceled. I've had to make a couple of adjustments to get it to run on top of DtCyber. Namely, I had to change these 3000 series disks to 6603 disks. And we don't have a satellite coupler attached to a 6-pack like this does. We also can only emulate one console at this point in time. I also added a printer and a card reader and a card punch, and it seems to work rather well. Let's see. But yeah, you can get good information on the Bit Savers page here and on this website here. And let's just kind of get into it here. First thing I have to do, I'm starting from nothing, is I have to run the memory test, because this will not dead start properly if the peripheral processor memory is initialized to just zeros. This only needs to be done once, because we actually remember the state of our memory after between runs. So once that's out of the way, just start this another time and get into it. All I have to do is basically initialize the packs. Well, I don't know, they're not really packs, they're big 6603s, are not disk packs. Anyway, this is going to set up the file system on those disks, basically. And I've prepared a backup tape that has program libraries that were found on this GRM1 tape for both the operating system and... I should keep this on top. So yeah, we're up and running now. And I just got to assign that dump tape that I made. This is going to restore some files and set up a validation file so we can use the batch system. We're basically putting these files back onto the disk so that we can easily work with them. I'm going to go through each of these steps here. I'm going to take this this file that had a bunch of 8600 stuff in it, and I'm going to separate it out into several different program libraries. One for the simulator and the cross assembler, one for all the 8600 native stuff, and one for the Fortran compiler for the 8600. I haven't actually built this yet successfully, but you know, I'm working on it. And then we're going to build the simulator, which also is going to build a very small part of the oh, we're done restoring. Let's get rid of that. Let's just go through, and since this is already fresh, I don't need to run the purge job. Let's just go ahead and so here you see the this is the simulator. This is the cross assembler. This is another cross assembler. I haven't played with this yet. And this is all the stuff for the native 8600 operating system and its utilities. And the Fortran stuff. Now to build the simulator. We basically are building the cross assembler and the simulator, and we're also building the 8600 monitor and the resident system library. We also are assembling the 8600 native version of libedit and using that to generate a very small starter library that has, well, you'll see in the listing here. I'm going to switch to that as soon as it finishes printing out. Okay. This is a listing of what we just built. I'm going to jump to the bottom here, and we're going to see actually, let me go through here. Yeah, Right around here in the job, we have just built up the resident system library and the monitor for the 8600. And right around here, we assemble the 8600 native libedit into a file named LE. And here, what we're doing is actually running the CPU simulator with a library that only contains the 8600 monitor and resident library, and causing it to execute the native 8600 libedit, and it's building a starter library for us that has a directory on it. You can see the output from that right here. That is actually produced by the native 8600 version of libedit. And this is all that's in our starter library. I've also added a directive just count to the simulator, and it will give us an instruction count of every 8600 instruction that was executed by the simulator during its run non-interactively in this batch job. Now that we have the simulator built, we can go on to the next job, which actually builds the full library of 8600 programs in several stages. Here we are using the cross assembler to build everything that's in the 8600 program library. And we call the simulator twice, once to build a full library without a proper native systext, and another second time to use the native 8600 version of Compass to build a systext that it can understand. I'm going to pause while that listing goes. It has everything in it as far as all the 8600 programs, the monitor. I'll show you in a second. So this is the cross-assembler listing, and this is the 8600 system monitor. It's actually not very large. You have the resident system library. I'm going to jump back to the end here because this is where we start building the libraries. Okay. So this is the first time we build the library. It has no systext in it, and that's on purpose, because the systext that the cross-assembler builds is in a format that only the cross-assembler can understand, not the one that the native one can deal with. So we call the simulator a second time, and build the systext with the native assembler. Now the cross assembler says Compass version 0, but the native one says Compass version 1. So we're looking at the systext listing that the native assembler built. And then finally, we build another library with the simulator. Well, the simulator was already running at this point because, yeah. But anyway, the simulator calls its version of libedit, and it builds another version of the complete library, inserting a new directory and a new systext into it. So now we're ready to run the simulator interactively. So let's go ahead and do that. Simulator is going to dead start off this library, which we've already shown you a listing of. These first two records are absolutely essential, and everything following them are all the utilities, plus the special directory entry that allows it to seek through this file and load any utility that it needs off of it by name. So what I want to do is there's two different ways you can call the simulator. If you call it like this, it will just take any cards following it in the job stream as directives or utility commands to call inside the simulator. You can also use an I argument to give it input from a file instead. But anyway, I'm calling the CPU simulator. I'm telling it to set everything up to run inside of DIS, and then I'm telling it to activate the DIS display. And when I let the job stream run, we are in the simulator here. We have a memory display on the left-hand side, and we have an exchange package on the right. And if you hit the equals key, you can change from relative view. I don't know what the P view is to absolute. If we hit plus, we can advance through this screen. And this is part of the 8600 monitor right here. We have pointers to the various libraries that are built when the monitor presets. And also, if you hit XP, you can switch between what I think is like what the monitor mode version of the CPU is doing versus what the exchange package is. I'm not clear on that. But anyway, this was all very useful for me. I'm going to move that back up to 0 and set it back to relative. Now, I can call list, which is the 8600 native version of what catalog would be under MACE library. And we've just run a utility inside the simulator. I'm going to take a look at the output, which actually requires me to leave the simulator. I'm also going to tell it to give us that instruction count, like you've seen in the listings before, but I'm just going to do that. Type end, go back to the AB display, and send this to the printer. And here we go. And with the instruction count, Now what I'm going to do is I'm going to use the native 8600 assembler and rebuild the library of utilities using the simulator itself. This is going to take a while, but I'm not going to record all of it. I'm going to skip through so it doesn't take so long. And by the way, these TU screens, this is a feature of DIS. It's kind of like the K displays, and you know, the CPU simulator uses that. So I'm going to go back and do. First of all, I got to grab the sources, so I'm going to do that. Okay, now we're ready to get back into the simulator. A neat thing about this simulator is that it can work with files attached to your job as inside the 8600 monitor, just like it was just a regular native file, you know, in the 8600. There's some sort of translation going on between display code and ASCII and all that fun stuff that I don't fully understand yet. But it really is quite transparent. And when I was trying to figure out how to build the library that the simulator dead starts off of, I finally figured out that I could put a utility on a file, and the monitor would search for a binary on a file first before it searched the library directory. And that enabled me to get this thing in a state to where I can actually do this stuff with it. So here we go. We're back in the simulator, and I am going to tell it to run its native version of Compass that we assembled earlier. And to use the systext that we also assembled earlier. And there we are assembling ourselves from inside the simulator. You can see the extra X registers that the 8600 has. You can see that we're working in hexadecimal. I honestly wish I knew a lot more about the 8600, but I mainly, over the last few days, have been just trying to get the simulator to work, looking at you know, assembly listings and whatnot. But there are no no address registers. There's no B registers. It's a 64-bit machine. And you know, there's a full set of utilities in here. Most of them seem to be direct ports of utilities that you'd see on MACE or NOS or Kronos. It's very bare bones, but it's got a full tool chain. And as I may have mentioned earlier, there is a native Fortran compiler that I haven't quite gotten around to building yet. But, you know, there's a bare bones monitor and there's a bare bones set of essential utilities and some diagnostics, I believe. And I think it's really quite impressive to have this type of simulator on a platform like this. I mean, as far as I know, no one has seen any of this stuff run since 1974. And that's mainly why I'm making the video, because it's going to be a while before I'm ready to make a pull request that would allow this image to run on DtCyber, and I want to kind of just document this while I have it fresh in my head. Anyway, I'm going to pause while it gets through this, and then I'm also going to show it running on the library that was built from the native 8600 assembler that is now assembling itself. Actually, yeah, just a moment. I forgot to set the correct field length, so we kind of ran out of memory. I'm going to fix that right now. So yeah. See you in a bit. Coming up eventually, we're going to find out that the native assembler running under the simulator does not like to assemble these two programs. I'm not entirely sure why, but the cross assembler does it just fine. But it doesn't cause our build to fail. It just doesn't insert. We just don't have the binaries for these two at the very end of the demo. And this is the part where we are going to get some errors. Still not 100% sure why we get this versus the cross assembler. I think one of these diagnostics also has one warning error too, which I don't see on the cross assembler. Okay, so now we have a new set of binaries. Let's make a new library. Okay, and let's get an instruction count before we exit. Set that to the printer. here's the listing. What we just did. The output from the native assembler looks a little bit weird. And I'm not 100% sure why, but it does indeed. Anyway, if we go all the way to the back, we get our libedit run, where we've replaced the new binaries, the old binaries with the new ones. And the ones that failed to build, we just copy those over. That's the way libedit works. We got our instruction count, which is, we did a fair amount of work there. Now, go back into this here. We got our library on new, the new one. I'm going to return the one that we made with the cross assembler. And I'm going to make the new library that we made with the native tools the new library. I'm just going to rename it. I think this is the right way around. No, I always get that backwards, but that's okay. Rename library equals new. There we go. This is the one that we just built using the native tools. I can go back into the simulator now. And start it all over again. Oh. What? Okay, I wasn't expecting this. There we go. I must have done a typo or something. But as you can see, it can rebuild itself using all the native tools and actually, have a running system, which I think is really, really cool. And really, at this point, I've kind of run out of things to show. So I hope you enjoy it, and I'm hoping to get this out to where you can get some hands-on with it yourselves. Have a nice day.